Hello and welcome to my channel Technobotic. In this tutorial, we are going to learn about two important concepts in data science, bias and variance. We will explore what do we mean by bias and variance, how they impact model performance, and how to find the right balance between them. We will also use Python code to understand these concepts practically in detail. So let's get started. I am sure many of you must have used dartboard. Let us try to understand bias and variance using the analogy of a bullseye on a dartboard. Imagine you are trying to hit the bullseye on a dartboard. Sometimes it may happen that the darts cluster together but miss the target entirely. This situation is shown in figure 1. In machine learning, this is analogous to high bias and low variance. At other times, darts may scatter all over the place on the board. This situation is shown in figure 2. In machine learning, this is analogous to low bias and high variance. At other times, darts may scatter a bit but still cluster towards one side, say top right. This situation is shown in figure 3. In machine learning, this is analogous to high bias and high variance. Finally, there may be a situation when the darts will cluster at one place near the center of the board. This situation is shown in figure 4. In machine learning, this is analogous to low bias and low variance. This is what we expect from a good machine learning model. Before proceeding further, let us make a quick note. High bias and high variance are errors in machine learning. For a good machine learning model, we want low bias and low variance, as shown in figure 4 in the last slide. Now, let us understand the definition of bias and variance. Bias is an error introduced by very simplistic assumptions while training a model. These assumptions simplify the problem too much, therefore introduce bias. High bias means the model is underfitting. Variance is an error introduced when a model is too sensitive to changes in the training data. High variance means the model is overfitting. In this slide, let us understand the bias and variance from the perspective of overfitting, underfitting, and right fit. In machine learning, bias refers to how far the predicted values are from the actual values on an average. A model with high bias tends to underfit the model. The first image represents underfitting. In machine learning, variance is the measure of how a model's predictions varies when trained on different data sets. High variance models can fit the noise in the data, leading to overfitting. The second image represents overfitting. I have written a Python code to visualize the underfitting and overfitting. In this code, I am trying to fit two models on the same data. One becomes underfit model and the other becomes an overfit model. I have used the NumPy, Matplotlib, and sklearn libraries in this code. NumPy is used to generate the synthetic data that we are using to train the models. The combination of linspace and reshape methods in NumPy is often used to generate evenly spaced numbers and reshape them into desired multidimensional structures like matrices. We generated the data using a quadratic function which is an equation of degree 2. Then we are using sklearn to split the data into train and test set. After that, we are trying to fit the data into a linear model. This will underfit and thus create high bias as the data is of degree 2 but the model is of degree 1, which means the model is too simple compared to data. Then we are trying to fit the same data to a polynomial model of degree 10. This will create overfitting and thus high variance as the model is too complex compared to the data. Then we plot how both the models fit the data. Let us visualize the output of this code in the next slide. On your screen, the black dots represent the training data points. The blue straight line represents the linear model which is underfitting to the given data. The all red lines together form a highly wiggly curve which covers most of the data points, and thus the model is overfitting. Our goal is to find a balanced curve between these two curves. The ideal curve should capture the essential trends without being too specific to the training data. As we just saw, models need to strike a balance between bias and variance to perform well. This balance is called the bias-variance trade-off. Let us discuss that in the next slide. The bias-variance trade-off means that if you reduce bias, the variance tends to increase and vice versa. This relationship between bias and variance exists because model complexity influences them. In this chart, I have plotted model complexity on the x-axis and model error on the y-axis. I trained the 10 different models from complexity 1 to 10 and plotted their training and test error. The crossing point between training and test error suggests the degree where model is complex enough to capture the patterns without memorizing the training data. This is the complexity that is ideal for a machine learning model in this case. This is also called the sweet spot where the model has balanced bias and variance. Therefore, this creates low errors in both training and test data. Now, let us have a look at the Python code that is used to generate this plot. This code is used to generate the bias-variance trade-off curve we saw in the previous slide. I generated synthetic data first using NumPy. Then the data is split into training and test set using sklearn. After that, I created two arrays to store training and test errors respectively. Then we run the loop to create different degrees of polynomial equations from 1 to 10. Each loop fits the model of different complexity. After that, we fit and predict on all the 10 models. Then we calculate and plot the training and test errors for all 10 models. Finally, we plot the data and find the crossing point, which we saw on earlier slide. We learned the great stuff. To summarize, the high bias happens due to oversimplification and high variance happens due to sensitivity to noise in the data. High bias leads to underfitting while high variance leads to overfitting. For high bias, the training error as well as the test error is high. For high variance, the training error is low but the test error is high. To fix high bias, we should increase model complexity, and to fix high variance, we should use regularization or use more data for training. We have come to the end of this tutorial. Thank you for watching. I hope you enjoyed this tutorial and found it insightful. If you learned something new, please like the video and share it. Also, you are welcome to share your thoughts in the comments below. Please do not forget to subscribe for more technical content, tutorials, and the latest updates. Also, please follow and subscribe to my blog on medium.com to stay connected and never miss an update. Thanks again for being part of this tech community. Until next time, keep exploring, stay curious, and see you in the next video.